Yeah, sorry.
Yes, doctor. Um, so, doctor, I looked into like electrodynamics was the topic which we discussed last, and I looked into the theory of electrodynamics, and I understood it. Like I found that it is applicable in many scenarios.
Hmm.
Uh, so I was able to like really understand the concept and why it is, why we are studying it and where it is applicable.
Hmm.
So one fundamental thing I understood about electrodynamics is that electrodynamics is the junction or the meeting point between electricity and magnetism. So we have electrostatics and electromagnetism is the branch which is subdivided into electrostatics and electrodynamics, which means we have a point where electricity and magnetism is converged. So by that logic, if we are looking, we can't find a point where classical mechanics and quantum mechanics is converging. Like they still remain two independent fields. So do you think it is because one of the theory is wrong, or because you don't actually need such a convergence?
What do you mean by convergence? Why do you think so? Why do you think so?
Like electricity as two separate entities and two different fields before Maxwell, James Clerk Maxwell, and then afterwards he was able to unify both of them. Maybe because what all theories we had about electricity and about magnetism both were correct, so we could like it was possible for him to create the four Maxwell's equations, and he was able to combine both fields. So if quantum like classical mechanics is kind of we know a lot of things, and but quantum mechanics is right now too abstract. So if there is no meeting, like if there is no convergence between both, do you think like quantum mechanics need a lot more revision?
See, everything is abstract when it is proposed as a hypothesis. Both are physical. It's all physical phenomena. Whether you are able to realize it or you are not able to realize depends on what level you are. The basic quantum mechanics is full of mathematical descriptions. Okay. So when there is a mathematical description, the physical aspect of the mathematical description require little bit of extra thinking. So sometimes what happens is it doesn't allow with the basic science. If you think basic science is biology, the quantum mechanics, see for example, energy itself is quantum. So when it comes to a biological aspect also, they have energy, right?
Yes.
Every biological behavior, pattern, interaction, everything doesn't come as quantum.
Yes.
So what is quantum where it is not quantum? Every energy comes as quantum. Every energy is basically electromagnetic energy. Then there is a question, what happens to the life force energy which people have? It's not just a thermodynamics or mechanical engineering. It is not electromagnetic engineering. There is a lot of other natural phenomena like life, thoughts. Everything is energy, right?
Radioactive decays.
Yeah, therefore the basic biology of the energy science of human being, all these looks like a contradiction. That is why quantum mechanics have got a lot of people don't even accept it. There are a lot of different thoughts coming, different proposals are there. Probably this may not be proved, this may not be approved by the classical physics people. Basically the propositions of quantum mechanics, including the light is the fastest and such things, if somebody questions it,
Yeah.
the whole physics, whatever so far learned, will have to be rewritten.
Yes.
So that risk nobody will take. So it take more time to understand. Assume that you are going to assess the temperature of sun, how the cosmology works, how the world moves. Everything, the basic principle is quantum physics. Because it's not somebody who observes, which I can see. The first sentence, what I said, it's a mathematical proposition. It is a hypothesis. Somebody is trying to prove that it is like this. Somebody also can try to prove that it is not true. Because mathematics cannot totally represent anything which is physical. It's all with approximations. So I can agree and disagree with any of the propositions. So any researcher is little biased. So it's a conflicting science. So that is why people talk about now the quantum mechanics in the context of physics, quantum mechanics in the context of biology. If you start reading, you will see in the quantum mechanics in which context you are speaking. In the context of physics, quantum mechanics is true. The context of mathematics, quantum mechanics is true. Okay. The quantum physics itself needs to be understood in a different way.
So, do you think it is essential for? We talk about classical mechanics for the classical bodies, like whatever we see for the celestial objects or for the macro world, and quantum mechanics is for the micro world.
See, quantum mechanics can be micro or yada pindhe tada brahmande. It can be for small or the large.
And the fast moving.
Yeah, anything which fast moves. The speed of light, when you talk about, you have to talk about the wave, we have to talk about the pattern, we have to talk about energy, orthogonal. Who knows? Whether it is only orthogonal or it is in any all directions, 360 degree. See, mathematics have to always talk about some referral x-axis, y-axis and talk about things, right? Suppose there is an energy on x-axis and y-axis. What happens in between that angle? There is no energy or what? The resultant vector is always there. But we always say magnetism on one axis, electrical on another axis. Then we know there is a flux. There is a... When you talk about light also, same rules are applied. Magnetism, same rules are applied. Electric, same rules. Even when you have got a flow, if some boundary condition, it flows orthogonal, we say there is a force. All these are quantum, right? We generally talk waves comes as quantum in the sea. See, these are all. Is it only true that there is only one way which we are seeing? Is it not there are another truff and trump in between? Harmonized things also can happen, right? So it's all conflicting sometimes. This is at a higher level. I don't. It's always there. There are a lot of conflict. Different people don't agree with Einstein's general theory of relativity because it's mathematically incompatible to one to another theory. Okay, so basically what is done is understand both and then somewhere you agree. The contradictions are agreed, but don't go to that level. Somebody talks about the space-time and then somebody talks about the space-time which is not with the wobbly space-time. Wobbly space-time is one way of resolving the contradiction of the physics theories, probably. There is nothing called flowless, seamless, quantum. Quantum means something like a one and then there is a gap in between, right? So then how do you say seamless? How do you talk about flawless? So fundamentally, there is some incompatibility between what is physically there, what is conceptually there. That is probably anything in science have to be explained through mathematics will have these contradictions and conflicts.
Doctor, do you think like it is essential for I know what I thought, like my line of thought was because electricity and magnetism could be combined, because whatever theories were developed in electricity, or whatever laws were developed in connection to electricity was true, and magnetism was also true, so we were able to combine both these fields. But do you think it is always necessary that a conjuncture is to be developed?
See, any wave, either light wave or any magnetism is also like a wave, sinusoidal. How do we represent all these? Sine and cos waves,
Yeah.
a combination of them. So there is a wavelength, magnetism is a wave, electricity is a wave, energy is a wave. There is a electromagnetic energy. The electromagnetic energy, when we talk about, immediately we say which wavelength it belongs to. Then we talk about X-ray, when we talk about all the gamma ray, beta ray. So the basic principle is there is a three-dimensional motion. X-axis is one wave, and the orthogonal there is another wave. A combination of that gives you a 360-degree movement in all the directions, right? So the basic electromagnetic energy is there not only in magnetism, not only in electricity. Light also has. When we talk about fluid mechanics, electromagnetic energy only. Heat conduction, electromagnetic energy. The heat is also an energy which is conducting in electromagnetic. But wavelength is different, that's it. Sound is an electromagnetic energy. What comes from me is an electromagnetic energy in the direction in which I am talking. But when I turn, the direction moves. X-axis, Y-axis is also moving. It's a dynamic moving X-axis, Y-axis around which you have got a 360-degree wave which goes. And as from the source, it moves like a 360-degree, like a funnel. Heat is also like that. So there is a source, it goes, the wavelength and frequency changes. It's not one x-axis, one sine wave and cos wave, right? It moves as the sine goes. Every signal. So when you talk about a signal which comes to your telephone, that also has got an electromagnetic energy, right? Gamma ray, beta ray. Why only you talk about the magnetism and electricity? The word magnetism and electricity is just to mention that there is an x-axis, there is a y-axis, it goes orthogonal 360 degree. The magnetic and electric power, the charge, is a basic concept in which electromagnetism is defined. So now no more consider that magnetic as the magnet, electric as the electric charge. It is only an energy. Every energy in the world in the subtle form is electromagnetic energy. The spiritual energy in people, the physical energy in people, everything is pulse. When my heartbeat also is a wave. When there is a wave, there is electromagnetic energy. That is why I said the bioenergy is the psychological energy, the intellectual energy, the frequency in which I match with somebody. Oh, he is intellectually sharp. I am also intellectually sharp. My waves are matching. Therefore, I have got a combination. Together, we move together to make a bigger wave. If two waves don't match, there is an interference. My memory will go, your memory will go, both will go disaster. That is why somebody matches with somebody else, somebody doesn't match with somebody else. So there is an emotional wave, there is an intellectual wave, there is a social wave, there is a spiritual wave, there is a physical wave. So it's all conceptually a wave, nothing more than that. So electromagnetic, when you say electromagnetic energy, electromagnetic wave, therefore there is a frequency, therefore there is a wavelength. Wavelength of two people are matching means what? Electromagnetic energy between them is matching. That is what is aura. Right. As long as it moves, it spreads. Light is also like that. Light is also electromagnetic energy between 0.4 to 0.7 micrometer. When the wavelength is different, give different color. That doesn't mean electromagnetic energy is not there. The wavelength is different, frequency is different. That's it. Sound is also like that.
Yes.
It's one of the basic subject on which everything is built upon. So you cannot contradict and conflicts and then create problems. That's one of the biggest thing to understand. So thinking that is fun, but I think that should be done not at when you are too much into research into that, probably. Otherwise you cannot build the physics. You will start contradicting yourself and getting into troubles. Basic mathematics is also like that. And in high school level we learn what is a set theory. Set is a defined objects in a class and all that we will learn. We go to master's level, we say set itself is wrong. There is no concept of set. It's all contradictions. So at some level, that's why I said depends on which level, what you are thinking, what you are speaking is. There can be convergence, there can be divergence. I may agree, I may not agree. It depends on to whom I am talking. So it's a good thought, but what is written in the textbook, just follow, don't try to contradict. Because that textbook based on those principles. Understood? Otherwise, like a student who don't want to go with a uniform in a school, every day he suffers. The rule says you are in that uniform. So once you are in the school, that rules have to be followed. So once you are following a book, what the author says, just follow. Read something else which contradict the book and then start reading, you will be in soup. Yeah.
Yes, doctor. I understand. Doctor, another one question was recently a lot of pictures were released by NASA regarding that was given by the James Webb Space Telescope. So when I saw the pictures, many of the images of the nebula, of the rings of Saturn, like many of the images that was released of the galaxies and other celestial bodies are all colored. And I learned that the images or these images which are captured are colored corresponding to the specific wavelength of the light that is emitted by the gases in the nebulae. So I saw a ring nebula which is whose inner cavity is colored red and orange, and the outer cage is covered with yellow or colored with yellow, blue, and all that. So anyway, those colors are not like what we perceive with our human eye, right? It is converted by maybe processed using an image processing technique or anything like that, right? It won't. The colors that are assigned to the celestial bodies are not like actually the true colors, right? They will be, what is the technique that is employed there?
Any color comes with from a camera doesn't have natural color. Assume you take a camera and then set your RGB in different. In your mobile itself, you have a lot of filters, right?
Yes.
So what is the filter doing? Your RGB combinations are remodified to match. It's like I am seeing a green item with a glass. How does it look like? It looks like entirely different when I use different color glasses.
Yes.
I am looking at a green with a green, it will look different. With a red, it looks different. Looks different. So any image which you see from a camera is not natural color. It's called a false color coded image, FCC. Read what is called FCC, false color coded image. For every scientific purpose, for what purpose I am looking at it, I will give a color code. Assume I am taking a picture of a snow region full of snow in Kashmir. I wanted to take a picture. There is no point in making a color image because everything is white.
Yes.
What I am looking for is a small road there which I wanted to get highlighted. So that road may have little bit black here and there. But my tree also will have black. But my tree is not really black, it is green. But it is not as fresh leaf as it is. So it looks almost like black. So what do I do? When I take a picture, I want to distinguish this blue with the curtain blue. So what do I do? This blue I take it to black, that blue I take it to perfect blue. So I readjust the wavelength, not in blue band, red band, green band. The blue itself I will cut it into 1000 pieces. So between 0.4 to 0.7 is the white light. I can make 1000 bits in that and then take one green which is close to the tree green, but that is not the green which the water may have some greenish color. But I want to distinguish green water with the greenery on the tree. All the green I will put red color, all the water I will put as blue color. So you will see the whole tree which is in the image will become reddish color. Generally all satellite image, if you look at FCC satellite image Kerala picture, you will see it is like reddish color in Kerala. That's how all the red colors are made. The FCC image of Kerala, if I type, I will get Kerala picture as a red color. The satellite image will become reddish like this. That doesn't mean there is a the trees are red. Yeah. I am assigning the green color to red so that the water information I can put it into blue so that everything becomes crisp and clear. Green is never used in most of the images, but when you see green, it is full of snow. So you see a satellite image like this. What is satellite image in this which I am showing? All the red is greenery, all the black is snow, all the green is urban land, cities.
Okay.
So you will see Delhi as green, Kerala as red. So that doesn't mean Delhi has lot vegetation. So it is called false color coded image, FCC.
So all satellite images are false color.
All the color pictures which you see from satellite image, for what application I am seeing, based on that I will assign a color for the wavelength in which I wanted to see. So assume that I wanted to see the sea surface temperature. So sea surface temperature is what I am looking for in the sea. You take an FCC picture of sea surface temperature in Arabian Sea. Then what you will see is the sea will have a red color there. The boundary will be somewhere red color, somewhere it will be blue. That means wherever temperature difference is there, I will give a color of red. So that I know, oh, there is a temperature difference there. Understood? That doesn't mean sea has got red color inside that, right? So we use different colors to represent the sea. You can see inside the India, and beside that you can see blue color and somewhere red. That doesn't mean there is a greenery there. That means the temperature is different there, because seasonal temperature variability observed. That's how I make my maps. Arabian Sea you can see like this. Green is there, white is there, red is there. So I am color coding the temperature variation in terms. How do I represent a color for a temperature? I will give a color code. That color code is called the false color coded image. It's all manipulated. It depends on what application I am doing. There is no basic rule. This is how I have to do it. It depends on my application, what I am looking, what I wanted to see more clear, distinctly different, for which I will make my own color. Therefore, all images what you see is a color coded image. That's how you do when you take a picture. You wanted to see your picture more better. You will do all the manipulations on RGB and make it clear. So your background will become dull, right?
Yes.
It's image processing. Basically, it's a basic image processing through lookup tables. Histogram adjustment. It's all through histogram adjustment. Basically, red histogram, blue histogram, green histogram I will adjust so that my picture looks what application, what way I want. And they're all not multispectral. They're all hyperspectral. there will be thousands of wavelength divisions in between 0.4 to 0.7 itself.
So based on the application, it will be different for. Yeah. Yes, sir.
And assume that I take a X-ray. In X-ray, your bone inside your body is seen as white color. The flesh is seen as black. Does it mean you are a black and then your bone is white?
No.
So which wavelength I am taking and what color I am giving? Same basic rule, no?
Yes. Doctor, another one doubt is once we discussed about how can you read a textbook, and you gave a different kind of thing. So now what we do is we have to collect research papers and read various research papers. So is there any effective mechanism to reading a research paper?
No, identify what is the problem. Write down all the technical terms and read one basic paper on which you are trying to work. You may change that later, but start with the one basic paper which finds you suitable to your route of research. And then look at the references. Which are all the paper this person has referred. And then look at on those papers which are referred. Then you will see, oh, I am referring something which is of 2020 in which this paper is referred. And there is somebody else who has published another paper in 2023 in which also this paper is referred. Then you are jumping from your 2020 paper to 2023 paper, which may be related, may be slightly related. Otherwise, they will not refer. So one way is to go back and then forth. So if originally what you are looking is the ultra modern, best new, the latest paper. By the time a paper comes into a journal, it will take 2 years. No paper is published on an overnight, right? Sometimes 6 months, sometimes 1 year, sometimes it takes 3 years. Probably what PhD has been submitted in 2020, the paper gets published in a journal 2023. By the time somebody else would have already worked on that and then published something else in 2022. Understood? So it depends on whether you are a student, whether you are a professional. So look at, in the same title, is there an invited article, special issues? Not just journal is a basic journal which comes yearly, comes bi-monthly, bi-yearly, quarterly, depends on the way they publish it. But most of the conferences and most of the invited commissions for different research areas, associations will make this has to be published very fast. So make a special issue. The special issues are generally fast published, but they are all published by experts, not students, not research scholars, not the lower level. So special issues will give a very specific reference to what is going on today in the world. That is what is to be done. Don't look at newspaper, don't look at science articles in magazines. It doesn't have any authority. I can publish anything, and just opposite, contradicting, I can give it to somebody else, they will also publish. Okay. So such, if it is not a reviewed journal, even conference peer reviewed, not even conference proceedings are to be considered as published. Authenticated is not, they are not authenticated. So look at the standard of the journal, start from somewhere. That's what is to be done. And look at the credential of the person, from which university he is, how many publications he has. No student will publish a paper by themselves. They will have a supervisor. With them, they will have a paper. So look at the supervisor's name, which university he belongs to, and whether that university has got a standard. See, 99 percentage of the publications which comes from India are, the whole world says it is foolish, repeated, old stuff which has no value. In most of the science publications, it's like that. Yeah.
So the papers which are available on public sites are not to be trusted, right?
No, journals peer reviewed, and some of the journals will charge. Why I am saying it is, suppose somebody has got a great publication from India, definitely he would not be working in any of the universities in India, because India doesn't, those universities doesn't have standard. It is only 200th standard for Indian Institute of Science in the whole world, right? So I'm sure somebody publishes from Princeton University will have a higher value, because that is why he joins there now. So which university, what comes? We all refer papers, we all publish papers. I was a student, I was publishing paper, but I was never referring some journal which is coming from Indian authors. They're all asked to refer to the well-known. See, for example, for every subject there is a standard journal, and that standard journal will publish people. No, we will hardly see somebody. In my time, I have hardly seen an Indian publishing paper in that journal, except one or two, my professor or somebody else. Right. So some of them have. That's why I said 1%. Because nowadays, why it has come very bad today is because every private university demands the professor to publish papers. UGC has given, if you don't have 60 publications per year, your university will not be a research university. You cannot have PhDs. So what do? Somehow they will publish somewhere. The online journals are many. They will just publish. Right. I am also a editor for some of the journals whom I even don't know. No paper comes to me. And even if a Indian philosophical some journal, I am an editorial board. Even if I say reject it, they will accept it, because somebody else will say accept it, right? So it goes like recommendations and commentaries. So it doesn't, unless it is referred by so many people, it is not considered as a great paper. So how many citations are there? It's called citations. If I write a paper, my paper is used by 10 people, then I have got that much credit. I write a paper and nobody is looking at it, then my paper has no value. It is not published paper. How many citations are there? So every paper, when you look at it, look for how many citations that paper has, how many citations that author has. That is called the credibility of an author, credibility of a scientific paper. Even social science or humanities or literature, language, anywhere, the publication is simple, but getting citations is very difficult, because publication is in my hand and the journal's hand. Somebody refers it, depends. See, I am publishing a video on my YouTube is not a great thing. How many people are seeing it, how many people are commenting it matters. Seeing is also simple. I can give an advertisement on my video. You will see none of my video has advertisements. That is because if I start monetizing, whenever something comes in question, that will be published first by the YouTube. It will get publication. So it's automatically, economically, for the YouTube money, for getting advertisements, they are doing it. Genuine are not like that. You are not doing it. Some journals, even the author has to pay money to get a copy of the paper, because they are very, very expensive, costly. So many people may not read. So what comes on online is free. Why they are giving it free? Because that much value only there. It doesn't mean all the free things are bad, but I am saying. So what do? They keep it for 10 years so that genuine people will look at it, genuine people will refer it. That's how they do it.
Yes, that when I saw one paper, which was that paper is actually written by, like, it is published by one person, and what he did in that complete paper, it was 11-page paper. So what he did in that was to just write down the all the developments that have happened in the field of black holes from the very beginning, like how the idea of black holes came, and then how it got transferred to different people, and how the ideas got transferred over the years. That was what is being discussed throughout that paper. So, is that an example of a literature survey, or
Yeah.
what is
See,
the kind?
what generally sometimes that's what I said. Some of the people are invited to say that, give a substantial, not a brief one, give an explanatory, elaborate introduction for such area of research which collaboratively somebody can read it together and understand this is what happened. So such invited, they are not actually research papers. Understood. Research means something new should come, but journals also can, or maybe special issues can have such things. Quite possible.
So that is a literature survey.
Yeah, possible. Yes.
Yes. And then sometimes all the steps will, like, if it is a derivation, everything will not be given.
No, it will not be.
So in that case, if we refer to the references, and if we look back into some papers, will we be able to get the missing steps?
Yeah. You should ask them, or maybe refer to some other papers.
Yes. Dr. Then one other thing was regarding the GATE exam. For, like, after MSc Space Science, the GATE exam which we can appear is for the aerospace engineering, because that is our syllabus is more of that than physics. So that is the paper which we are supposed to take. So what are the opportunities for a PhD? Like, GATE score is valid for a PhD, but is it useful for a PhD in astronomy, astrophysics, and all that? Like, is there a link?
See, GATE is not just for PhD. Tomorrow you want to do MTech. After MSc, people can go for MTech also.
Yeah.
Many people go after MSc because BTech is the basic qualification for MTech. But BSc, MSc is 5 years. BTech is 4 years. So BSc, MSc is almost equal to BTech. No, though not a technology. So you assume that tomorrow you want to shift it to technology. You want to do PhD in technology department, not science department. That will give you a jump from science to technology. So GATE will give you a qualification to do an MTech. Number one. Number two, some of the universities, including abroad, they consider GATE as one of the, okay, GRE is must and all that is must. GATE also can be considered sometime. Third one, assume you want to go to IIT for higher studies. Even for a PhD, GATE score they will look at it. Most of the companies like BEL, BHEL, all of them will look at your GATE score, because that's considered as much higher value than the marks, because marks everybody can give. I am an autonomous university. You are my student. I can give you 100 out of 100. But same subject, same questions in GATE, you may not even pass. There are many such cases in India. Therefore, GATE is like a standard test, like an entrance examination. Okay, if there is no entrance exam for masters, consider GATE as one of the certificate of where you can show that and then get. When you go to with the GATE for MTech, you get fellowship. Some universities you can go for MTech without even GATE. But your MTech will not be approved by AICTE. So without GATE, MTech is different because university is giving. When you have GATE and have an MTech, AICTE is giving you the MTech degree. So if you want a all India recognition for your MTech, GATE is must. So GATE has got a real validation. So better to write GATE. Getting good score in GATE is not that easy. Even with the BTech and MTech, people don't get. Even after MTech, people write GATE. Right. So it's not for admission alone. It is like a litmus test for your knowledge.
Yes.
But
Yes, I
prepare
agree.
with old question paper. Prepare with old question paper. Thoroughly do it. Probably what you prepare for GATE, 80% of GRE is done. Any abroad admissions, we have done some GRE preparation, GATE preparation, all of them looks almost the same.
I did look into the syllabus of the thing, and that is when I understood that ours
It
is
needs a very dedicated preparation.
yes, sir. So these were the major doubts that I had.
Okay. So I can publish this on YouTube, right?
Yes.
Yeah.